We have a triangle ABC. So using the law of sines, we need to show that sine b minus c over sine b plus c, that's given by b squared minus c squared over a squared. So let's try to understand it. So we have an acute angle triangle. So for simplicity, I'm using an acute angle triangle with vertices A, B, and C. Now, the side opposite to angle A, we're going to represent it by A. Side opposite to B, that's represented by B in lowercase, and the side opposite to angle C will be represented by lowercase c. Now, the law of sine states that we have A over sine angle A equals to B over sine B. It will be equals to C over sine C. We can hold this will be equally true for the ratio sine A over A equals to sine B over B equals sine C over C. Right. So let's try to use this idea. So we will start from the left hand side. Now on the left hand side, so we can start either from the left hand side or you can start from the right hand side. That's totally up to you. But for this particular case, I'm going to start from the left hand side. So we start with sine of B minus C divided by sine B plus C. What we'll do, we'll multiply both the numerator and the denominator with the expression in the denominator, which is sine B plus C. We're going to get sine B plus C multiplied to sine B minus C whole divided by sine B plus C. The reason why we wrote in this particular fashion, because sine B plus C times sine B minus C, that this is actually the expansion of sine squared B minus sine squared C. So sine squared B minus sine squared C divided by, now we have in the denominator sine B plus C. But we know that our triangle, the sum of the angles, sum of the interior angles, so that's A plus B plus C, that sums up to pi radian, which means B plus C can be also represented as pi minus A. Now, if we take sine of the angle B plus C, so this is also the same as taking the sine of the angle pi minus A. Now, what is sine pi minus A? That's simply sine of A, because pi minus A lies in the second quadrant. So we have a positive sign, and pi means we have an even multiple of pi over 2. So therefore, in place of sine B plus C in the denominator, we can simply use sine A. So that would mean, okay, I made a mistake here. So it's sine squared B plus C. So we're going to get sine squared A. Now, using this fact, so we can use this a particular idea. So we have sine A over A equals to sine B over B equals to sine C over C. So we are going to suppose, so we're going to consider that all these ratios are equal to a scalar lambda. Then we can say that sine of A will be equals to A times lambda. Similarly, sine of B will be equals to B times lambda, and sine C will be equals to C times lambda. Right. So let's substitute these values into a ratio. So we have, in place of sine squared B, we're going to have B squared times lambda squared, minus, in place of sine squared C, we're going to have C squared times lambda squared, whole divided by, so we have sine squared A, so that will be A squared times lambda squared. So we can factor out lambda squared from the numerator and the denominator, leaving us with B squared minus C squared divided by A squared, which is the expression on the right hand side. So this is how we can show that sine of B minus C over sine of B plus A, that's equals to B squared minus C squared over A squared, if using the law of sine. Now, if we want to start from the right hand side, now starting from the right hand side will be fairly easy. All you have to do is consider this ratio. So here, if we consider that this is equals to some constant lambda, then A will be equals to lambda times sine A. B will be lambda times sine B, and similarly C will be lambda times sine C. You can substitute this value back into B squared minus C squared over A squared and do some algebraic manipulation, and that is going to give you the expression on the left hand side.